All right, so this will be a very short presentation. I just talked for about 10 minutes. First, I quickly want to thank the organizers, of course, especially Martin and Denise and everybody who made this event possible, also the sponsors. Thank you very much for having us. So we are Miracoy, and we're a small startup company from Switzerland. Just have to make sure my laptop doesn't fall down here. All right, don't breathe. So we're a small startup company from Switzerland, and we provide CAD software to do intuitive, fast, and precise 3D CAD. And I want to talk a little bit about the journey that took us to us providing 3D CAD software, because we have a signal processing background. We're a spin-off from EPFL, from the Swiss Federal Institute of Technology in Lausanne. And we were actually at the beginning working on biomedical shape characterization and just modeling for biologists and clinicians and people doing clinical research. So this is a video I'm going to start in 1 second. Just quickly to give some context, the green structure is a very noisy brain outline that stems from 3D MRI data. So a patient goes to the scanner, acquires a 3D scan of his head or her head, and then the clinician wants to extract the brain in order to do some analysis of, for example, Alzheimer's disease or neurodegenerative diseases and so on. And so the clinicians came to us as researchers. This is really early days of my PhD research 5-6 years ago, and told us about this problem, and they wanted to characterize this brain structure. So as you can see, the green structure is very, very noisy with a lot of artifacts, and they want a very smooth and precise model of the brain. So we came up with an algorithm that actually allows the clinician to segment this data pretty fast. So this is 4 times accelerated. So he can do that, or she can do that in a doctor-patient encounter within 5 minutes. And actually the requirement is also that once this brain structure is segmented, the clinicians still want to go and tweak and adjust a little bit the model to increase the precision. Everything should be super smooth. And in the end, you get something like this. So this is really just a brain outline without any skull or bone or none of that. So here's another example of, again, a 3D MRI image. This is the aorta. So this is the heart region. And again, the clinician, they want to outline or segment this structure, and then they want to be able to tweak a little bit the models to increase the precision. So, sorry, I just have to remove the underlying laptop, otherwise my laptop will fall down. Sorry. All right. So this was the early days of our research, and then actually 3 or 4 years ago, there were some folks in the AEC industry that told us, I mean, they saw what we were doing, and one of the requirements for the clinicians was it should be very, very intuitive. So no clinician is ever going to use Rhino or SolidWorks or any of that because it's just too complicated. Clinicians really want something that's fast, no learning curve, and just apply it and it works. And so some folks from the AEC industry approached us and they told us too, we also want that. We also like things that are simple to use, things that are very intuitive and deliver precision. So that's how we started to work on the technology transfer to bring that framework into the AEC industry. Our framework already back then was called Xyrus, so this was the internal research name. And now we brought the geometric Xyrus kernel to the AEC industry. And here I just want to present you a couple of features that we have for the people doing 3D CAD in the AEC industry. So this is all about smooth, organic, free-form shape modeling. So some characteristics, it's direct smoothness control that we offer. I will show in a second what this means. Decoupled access to the surface, tangents, curvatures, tangent planes, higher order derivatives, watertight junctions with G0, G1, or G2 smoothness control, subdivision, it's NURBS compatible, and so on. So I just present you a bunch of quick videos so you see what this is about. So first thing, direct surface control. So this is software that we make compatible for Rhino. As you can see here, this is actually just a plane that you manipulate, and maybe for the people who know Rhino or know NURBS, you can see that this is pretty unusual because you can directly touch the surface when you deform it. When you deform it, it deforms very smoothly. Now for the people who don't know 3D CAD, you would believe, well, this is how it should be done. You know, it's just, you just touch the surface. There's no parameters in the air, no control points, no weights you have to adjust. So this is basically what the clinicians asked us to do. So we worked on the theory and did it. And then we brought it to the Rhino world. Another example is decoupled smoothness control. So we actually allow to manipulate tangents, curvatures, tangent planes, higher order derivatives. And we call it decoupled smoothness control because you can manipulate these quantities independently from each other, which means that, for example, here you can see at each control point location you can display the tangent, you can move the tangent. This is very, very simple, but the control point itself on the surface doesn't change the position. So you're just moving the tangent and not the control point. The same thing you can do with curvatures or tangent planes, and you can really adjust these quantities in a decoupled manner. So if you spend some time to adjust some curvature value, this will stay there. Then you can spend some time to adjust the tangent value. You can spend some other time to adjust the surface point. Everything's decoupled. So this gives you actually some kind of new freedom to operate, or freedom of operation when you do 3D CAD. This actually gives you new ways of doing surfacing or come up with surface shapes that you cannot do if you just have this very classical NURBS-based control point structure. Maybe just I switch forward the video to show you something about tangent planes as well here. Sorry, just very quickly, because I know everybody wants to get the drink. Okay, sorry, it doesn't quite work. Well, anyway, I will show you another video in a second. So another thing that people in the AEC industry that work with us, they really, really jumped on this. We didn't know this is such a big deal or such a huge requirement, but it's to create watertight junctions between surface patches. So what we have come up with is a very, very simple way of just choosing patches, choosing edges on patches or subsegments, and just connect them, and it's independently of topology. So for example, here you can just connect a box or a square shape to a cylinder that has a circular shape, and you can just choose what kind of continuity you want. So you have, for example, different options. You want G0, G1, or G2, and then you can just, with a bunch of mouse clicks, get some previews, and then you can choose the one you want, and you have it, and this is basically, if you apply an offsetting operation, you can manufacture this surface. So this is really, really quick, very simple, and just gives you some kind of new opportunities to do some surfacing. In this example, you can create a star point or a star junction. So some of our collaborators really, really like to manipulate or to adjust the continuity at star points and star junctions. For example, when you do piping or create some complex roofs of buildings, and so on. Then another thing I want to insist on or highlight is this is 100% NURBS compatible. So it means that at any point during your modeling framework, you can change the Xyros structure into a Rhino built-in NURBS structure. And then you can just move on with your NURBS-based modeling workflow, or if you have certain scripts or your modeling pipeline depends on NURBS, you can just apply it. And it also works backwards. So you can also have a NURBS object and just convert it into a Xyros object, and as soon as you do that, you have access to tangents, tangent planes. You can modify the continuity between surface patches and the junctions, and so on. So this is really both ways backwards compatible. Another thing that I want to highlight is that every single NURBS command or BREP command, if you know about the Rhino modeling workflow, is applicable to a Xyros object. So even if we don't specifically provide this operation yet, you can, for example, do trimming, offsetting, filtering, chamfer, all these kind of things. Just apply any NURBS command to this object and it works. Subdivision local refinement. So this is actually subdivision compatible. So we have our own native Xyros subdivision algorithm. So this is especially useful if you do local refinement, if you want to add certain details to the object, to the surface, or to the volume. So you just can introduce a new control point. Again, the new control point keeps all the characteristics of any other control point. So again, you have this access to higher order derivatives, curvature, and so on. So this is, again, really, really simple and supposed to be intuitive. Then the last point is it's free. So you can just go to our website, you can download it, and it's completely free. This is because at the moment this is still an alpha version, and it's actually quite robust. We work with a lot of people in the architecture industry, jewelry industry, industrial product industry, also furniture design, and so on. And we really try to get as much feedback as we can from these people because it's the users who help us to shape the final product. So we really try to engage in conversations and get the feedback so that we can actually understand what are the needs, because again, we are still signal processing people and we started in biomedical imaging. So if you like what you see, then just go to our website, download it, engage in a discussion with us, send us an email, go to our forum, and just tell us what you would like to see there, what you think is not working, what is missing, and what kind of features you want to have in the final product, and we try to think about it. All right, thank you very much. That's it. Have a nice cocktail.